In this video, we'll be going deeper into stoichiometry and learning more calculations. First, let's look at a question. How many moles are in 25.2 into 10 to the power of 21 molecules of CO? CO. In the previous video, we learned how to find the moles when we had the mass and the molar mass, but over here we don't have that. But we did discuss about the Avogadro's number, which was 6.02 into 10 to the power of 23. We said this is 1 mole. So if this is 1 mole, we can divide this by this value to see how many moles are there. All we have to do over here is 25.2 into 10 to the power of 21 by 6.02 into 10 to the power of 23. Now we have to do a bit of surds. We are going to bring that here and then multiplication. So this is going to give you a molar if you solve this 0.043 mole. This is all you have to do when you've been given the molecules instead of the moles. How many number of molecules are there? 5,000, 50,000. You just need to divide it by the number of molecules in 1 mole. Now we are going to move on to volume of gases. Avogadro's law states that equal volume of any gas at a given temperature and pressure will have the same volume. It says equal volumes of any gas at a given temperature and pressure will have the same volume. And there is continuation to this at STP, that is standard temperature and pressure, one mole of all gases will occupy 22.7 dm cube. This is very important when it comes to gases because our formula is going to be based on this. Just keep this here. With this information, we can construct a formula. What we want is a mole. So we're saying this is just a different way to represent 1 mole for gases. Just like this, instead of saying 1 mole, we're saying 6.02. Over here, instead of saying 1 mole, we're going to say 22.7. That's the volume 1 mole of gas will occupy at STP. So we need to find out the question. Suppose they tell us, okay, let's just write this formula for now. Volume. You have the volume given in the question and you want to find how many moles that is. You want to see the amount of space it occupies divided by the amount of space 1 mole occupies to see the number of moles you have. One more thing that's very important over here is that the question should have STP written in it, because at standard temperature and pressure 22.7, at a different temperature and pressure it won't be 22.7. Now let's take a look at the question. How many moles are in 53.2 liters of lithium hydride. 53.2 liters of lithium hydride. Now you might be confused by the word liters. Liters and dm cube is the same thing, so you don't have to worry. This over here you can see 22.7 dm cube or liters or 1000 centimeter cube. You need to know this conversion. 1 dm cube or 1 liter equals 1000 centimeter cube. Now let's solve this question. Let's use a formula. To find the number of moles, all we have to do over here is mole equals, again this question, let's just say it mentioned STP, at STP, right? Or else we can't use this. So mole equals 53.2, that's the space it's occupying at STP. 1 mole would occupy 22.7, so how many moles are there? If you do this division, you will get 2.34 moles. We need to look at another basic calculation for stoichiometry, and that is concentration. Let's just divide these sections. Volume. Now we have concentration. In chemistry, it is crucial to know the concentration of the solute in a solution and control this amount, as the results of reactions or experiments can vary with changing concentrations. So we will learn how to find this concentration using the amount of solute and volume of solution. Amount of solute over here is measured in mole. Our volume of solution is measured in dm cube. So our concentration equals amount of solute volume of solution. This is our formula. Let's work out some questions now. What is the amount of salt in 5 dm cube of salt water in 5 dm cube of salt water with a concentration of 2 moles per dm cube. 2 moles per dm cube. So what are the two values we have over here? We have the volume of solution, that's 5 dm cube, and we have the concentration, that is 2. Volume of solution that's given over here 5 dm cube, the concentration is 2. We need to find out what is this. To that we need to make our amount of solute the subject, so we'll move 5 to the other side. 5 into 2 equals the amount of solute, and that would give us 10. So our answer is 10 mole. Simple. Let's look at another question. But this question is gonna have more than just concentration. We have learned all the basics, so we are gonna look at question that involves calculations that has that where we have to use more than one formula. So, how much volume will will have 45 grams of H2O2 occupy at STP? How much volume will 45 grams of H2O2 occupy at STP? Over here, it's a two-step calculation, two formulas. When we are looking at volume, we need we need to give a volume the formula in the form of dmq, but what we have is grams over here. So what we are going to do is we need to find out the moles over here. So with this 45 grams, moles equals 45 divided by, we need to find the molar mass of hydrogen peroxide, which is this compound over here. I already done that. That's 34. It's easy. We discussed it in the previous video. So that's our number of moles, which is 1.32 mole. If you do the division, we have a moles value. Now with this, we have to find the volume. The volume formula is moles equals volume by 22.7, right? Now we have two values, 1.32 and 22.7. So we need to find out the volume. To find out the volume, 1.32 into 22.7 will give you the volume. If you move this to the other side, division becomes multiplication. You're moving the term. And this will give you the volume as 30 dm cube. 30 dm cube. Suppose in such questions where you have to do multiple calculations, you don't know what to do, just look at the signs. Look at the units. Over here you have grams and you have H2O2. They're given this for a reason. You use grams only in one formula, which is mass by molar mass. So you'll use that to find moles. And then the value you get from that, you need to check it with the volume formula. If the volume formula has moles, yes it does. Then you can substitute in the values and find the volume. Let's look at another question that's similar to this. What is the concentration of 2.35 into 10 to the power of 22 molecules of carbon in 10 moles of pig iron? Pig iron is nothing but iron with other things in it, other elements mixed with it. It's not pure iron. But over here, what do we need? We need a final output needs to be concentration. And what's the value we have been given? 10 moles and 2.35 into 10 to the power of 22. Now let's just take the concentration formula first. Let's see what all we need in the concentration formula. Concentration equals amount of solute, just say solute, by volume. Over here we know that amount of solute is this. You're saying how much of carbon is there in pig iron. So that's your solute. Let's just say this in liquid state. So Solute, we take it in moles and this is taken in dm cube, right? So we need to convert this to moles and this to dm cube. Converting this to moles is easy. Just take a look at our formula, the first one we discussed in this video. 6.02 into 10 to the power of 23. So 2.35 into 10 to the power of 22. So it will be 2.35 by 6.02 into 10. 2.35 6.02 into 10. That is 2.35 by 60.2. So our moles, if you do this division, you will get 0.04 mole. And that's your final answer for, final input for your solute. 0.04. We have it in moles, so we're putting in the moles. Now we need a value for dm cube. We need to convert this 10 moles to dm cube. First, we need volume. Does the volume formula have moles in it? Yes, it does. The volume formula is mole equals 22.7 by volume. I recommend you have all the formulas next to you so that you can quickly look at them and get an idea on how to solve it. So our moles over here, we know the value. So 10 equals V, let's just say V for volume, 22.7. So 22.7 into 10 equals volume. So that will become 227 equals volume, right? Basic calculation. Now all we have to do is substitute in the values in the formula. 0.04 by 227. Because our volume is in dm cube, we got a value in dm cube. Our solute needs to be in moles. We have a value in moles, so we can just do the division, which will give you a concentration. Let's just say it's very dilute. The value is 0.00018 moles per dm cube. This is all for this video. Thank you so much for watching. Subscribe to our channel, like the video, and comment down your thoughts and doubts.